what we will discuss over in this is EVPN VXLAN implementing in the Nexus, and we'll go through the configuration steps first. Let's first discuss about how the topologies look like and all. So first thing, we have a spine and two leaves connected, and with two leaves basically that is connected to two hosts, and the hosts are connected with VLAN 10. So we are doing a layer 2 stretch. This example is based on the layer 2 VNI, how we stretch layer 2 across a layer 3 fabric, right? So the loopbacks 2222.111 at leaf 1, 333 in leaf 2. So we'll discuss about the concept associated with EVPN VXLAN and using Nexus. First, build the infra of the DC. So infra of the DC is basically divided in three parts. Underlay. We should have a OSPF or ISIs to be configured as an underlay. We can configure eBGP as well. Based on my topology, I configured as OSPF for the reachability, right? Just to have a reachability from L1, leaf 1 to leaf 2. The second part of the infra that we need to configure is overlay control plane. So overlay control plane with EVPN VXLAN is done through BGP EVPN. So BGP EVPN will able to learn those MAC addresses and advertise to the other side of it in the layer 3. So we have a route reflector as a spine, and we'll have BGP EVPN address family only configured with leaf 1 and leaf 2. So that will give us a mechanism by which we'll able to communicate between one another, A to B, so that my leaves will able to learn these MAC addresses from A and B and then advertise. The third part is overlay data plane. So overlay data plane, we need to have a VXLAN to be configured with it's a tunnel that we need, and VXLAN required in Nexus is required an NV interface, that is network virtualized edge interface. And the purpose of this is to have the data plane exchange in a bidirectional VXLAN tunnel based on two logical endpoints. So my native packet will come, I'll have a VXLAN tunnel. Based on top of VXLAN, we'll have UDP, then IP, and then MAC address. So VXLAN tunnel will give us the L2VNI information, then we'll have a UDP, and then we'll have a MAC, IP, and then MAC. So leaf 1 will encapsulate the packet, and leaf 2 will decapsulate it, and then we'll deliver the packet. So in Nexus 9K, we need to enable features for everything. So for example, like NV interface, we need to enable features. For OSPF, we need to enable features. For BGP, we need to enable features, right? For EVPN, we need to enable feature. Without that, it will not able to proceed. So first, we need to enable feature OSPF so that we can configure OSPF, then feature BGP. Only feature BGP will not help here because we are having EVPN. For that NV interface, we need to enable feature NV overlay. So that is my tunnel interface. And with that NV overlay, EVPN to be required to be enabled there, so that I'm able to configure BGP address family EVPN. And then feature VN segment VLAN based, which is basically mapping the VLAN to the VNI number. So VNI number is VXLAN network identifier, which will help to identify what is the other end, that which interface, which VLAN that the packet will decapsulate and send it across. So here the example is L2VNI. So L2VNI, both the sides should be same. And then often in the data center, we will have VM moves. So we need to enable feature fabric forwarding, which is a kind of Anycast gateway that we can configure. So Anycast gateway is nothing but will have a MAC address same MAC address we can configure in both the leaves because it's in the same VLAN. So that's the reason we need to have the same MAC address, fake MAC address that will configure in both leaf 1 and leaf 2. So first thing is I'm just configuring the IP addresses, then feature OSPF, and then configure feature OSPF and the OSPF underlay in my leaf 1. Similarly, I will be configuring with leaf 2 and spine as well. So this will give us the reachability. First the interface address, loopback address, and then feature OSPF. Once feature OSPF is done, then OSPF configuration. So leaf 2 and then followed by spine. So no switch port is required in Nexus so that we can able to configure the IP address because this is a switch, L3 switch, and we'll need to configure the loopback here as well. So router OSPF, feature OSPF, and then router OSPF to configure for the reachability purpose. So OSPF neighbor is up. I'm able to ping from 22221. Then BGP configuration, only BGP will not help feature BGP. So we need to enable feature NV overlay. So feature NV overlay and then NV overlay EVPN that will give us and enable the address family L2VNI VLAN. Send community is required because in order to send the extended communities. And here my spine 1 is acting as a route reflector. So I need to configure both leaf 1, leaf 2 as a client and spine 1 as route reflector. So it will take time to BGP to come up. So BGP is now up. Now I will configure the feature in the VLAN and NV overlay. VN segment VLAN based and fabric forwarding feature at leaf 1. So VLAN 10 and then VN segment 10010. So this will map my VLAN, and basically in Nexus 9K, Nexus 5K specifically, these have ingress and egress TCAM. So we need to enable that, and we need to configure to give the ability in order to accommodate the ASIC from the TCAMs. So we need to reslice the TCAM using the hardware access list and TCAM regions, right? So NV interface that we configure, host reachability with BGP, source interface loopback, and ingress application used by the BGP as well. So if I see that encapsulation is VXLAN here, and NV interface is up. I configured the Anycast Gateway as 001, which is same. I need to configure the same thing in leaf 2 as well, because I will have the same gateway address all across the devices, means leaf 1 and leaf 2. All the features that we need to enable, and once the feature is enabled, then with VLAN 10, we'll enable the VNI, and with NV host reachable using BG protocol BGP, and then source loopback address VNI 10010 ingress application for bump traffic using BGP. So now my NV interfaces are up. Fabric forwarding MAC gateways same across both the leaves, calling that under the VLAN 10 for the gateway. So still there is no route exchange between each other. So again, here also I'll configure the hardware access list, TCAM, region, routing ACL 512, which we have 256 as well. Then ARP, EtherARP. This command, we need to reload the box in order to make it effect. So at the access side of the interface, switch port mode access. Now let's say configure the different VLAN. I'm having VLAN 10 at leaf 2, and here by mistake I have a VLAN 100. What will happen? My NV interface will not come up. So my NV interface will not come up. I'm not able to ping, first of all, two different VLANs that cause an inter-VLAN, for example, routing. So there is no inter-VLAN routing yet. So I configure a static MAC to understand, okay, this is coming from host 1. So 001 is host 1. So ping my own address, able to ping that. If I ping 10.112, I will not. So here I'll configure 10.112 and MAC address as 002.002 cafe. So here configuration has been done. If I initiate a ping between 10.111 and 10.112, I'll not able to ping because of the VLAN mismatch. And then if I'll see that L2VPN EVPN neighbor and advertise, I'm not advertising anything to my neighbor yet. The reason, the peers are also not there. So we need to configure the EVPN. So with EVPN, we need to enable the VNI and make sure it is L2 that supports L2VNI. And then we should have a route distinguisher auto. So route distinguisher auto is by default, it will take the interface loopback address and 32777. We'll see that. So route target both auto will configure, and based on that, our route targets will be also configured as auto. So both sides we need to configure EVPN, VNI, L2, and then route target auto, route distinguisher auto. So once we have these configuration done, then we'll see that my NV peer is up or not. So now also NV peer is not up because I'm not able to exchange packet because of the VLAN mismatch. So if you see that if I'm advertising to the route reflector 333, here only I'm advertising my route as a route type 3 with 1111. So looking at the system internal F2 forwarder MAC, I'll see that there is no MAC that is being learned from the host. So if I check, if I go and do a packet capture, still I'm not getting any packets from the host yet. So if I initiate a ping, I'll not get any packet, any ARC packet here. So kind of troubleshooting, just I want to show you the troubleshooting. If I see that, okay, the interface is still down and it is in VLAN 100. So VLAN 100, where is that is the main problem that we are facing now. So if it is a VLAN 100, other side is a VLAN 10, that means there is a problem. Let's make this effect. Let's restart the box and let's make that effect whether the TCAM configuration is properly done or not. So reload the box, leaf 1 and leaf 2 because we configure the TCAM region over there. So once we reload, now we'll able to see, let's see if even with these different VLAN, what is the condition, right? So if I check my 10.112 ping and then go to leaf 1, show interface brief, and then still it is down, right, inactive. So now Ethernet 1/3, I'll make this port as VLAN 10 and then see what has happened next. So if you look at it, right, and then if you look at both the side, the interfaces are up now. Still ping is not yet done. I'll check the system internal L2 forwarder MAC, whether I'm able to learn. If you see here, VLAN 10, now learn the MAC address. Now BGP will able to advertise that. So BGP advertise route type 2 with the MAC address. I initiate a, so I'll see that BGP L2 EVPN, and then you will see that both the MACs are being learned. And then if you see the route distinguisher 1.loopback and 32777, that is automatically derived. L2VNI is 10010. Now the MAC from both the side, it been learned. And if you see that 22002.001, both the side, we will have MAC. And now let's clear the MAC address table and then reinitiate the ping and then see how it is happening. So initiate the ping is working fine from host 1. We'll have both the MACs and then we'll have the NV peer up internal L2 forwarder MAC address. Both MACs are being learned there. So MAC address table. So we'll see that MAC address table will have the static. So for example, if I initiate a ping and do a packet capture, right, and then we'll be able to see how the packet is going forward. So if I ping from host 1 to host 2, right, and then do a packet capture. So in this packet capture, what we are able to see here. So in this packet capture, let's stop this packet capture, and we'll see that the packet which is a native packet. So my interest is packet which is coming to leaf 1, and I'm capturing that packet. So what if you see that this is my native packet. This is the Ethernet header of the native packet, which says that source is 002, which is coming from there, and destination is 001. Let's see the request packet. So request packet, I initiate a ping from host 1, which is 001 cafe, and the destination is 002 cafe, right? If you see that in IP packet, I have a source address as 10111 and destination is 10112. This entire packet in the data, ICMP. So this entire packet get encapsulated with VXLAN. So VXLAN, if you remember, we configured the L2VNI as 110, right? 100 and then 10. On top of that, we'll have a UDP header, destination port 4789. Also, we'll have an IP address, which is leaf 111 and destination is 2222. And then we discuss about the concept. We discuss about the different route types in my previous video. Now we just started with L2VNI stuff and saw that we will have a route type 2, which is advertised by the device, right? Now we're able to understand how a native packet is being encapsulated with VXLAN and then deliver it to leaf 2, decapsulate there, and then deliver the native packet towards host 2, right? So it's like a layer 3 fabric, and we are sending the packet from host 1 to host 2 as a layer 2, doing a layer 2 stretch without going to the default gateway. I'm just initiating the communication between them. Thank you for watching.